then another record here. So basically for the lab session, as you can see what I have shared in the e-learning system, if you scroll down, okay, if you scroll down to after your mini project, there are some lecture materials related to practical. Okay, I have dragged some of the PDF files here, which is practical lecture 1, practical lecture 2, 3, 4, and 5. Okay, so that you can download. So this material is basically, it was not me who was preparing this material at first place, because this material has been prepared by Professor Dr. Ikman Nizam, the lecturer who has delivered this course before. Okay, Dr. Ikman has prepared all of this material, a module for practical lecture. Okay, so basically I will be based on this practical lecture, but to make sure that this is much more easier for me to deliver during class, what I am preparing now is I am preparing this sort of because as you can see from that module, from this practical module, it is something like this, which is it is like something like this, which is like a manual that it is hard for you to just read and do it using your online session, right? So what I'm doing now is to extract some of the information from this module, put it in the lecture slides that I have here. I'm still preparing this lecture slide that I'm going to share. I will be sharing with you guys later, this lecture slide. And maybe in this lecture slide as well, I will add some more information related to, for example, this LT Spice session. I will add more information, which is not only available, which is the information might be not available in the practical lecture module that has been prepared by Dr. Kima. Okay, so for PowerPoint slide ni, I will share with you guys later before we begin our live or lab session lah. Right? So that is about the module. So basically in this practical lecture, so we will cover about 5 topics. Okay. Topic 1 is electronic software, which is in this electronic software, like has been explained before, we will explore on how to use LT Spice, which is the software that we can use to construct the circuit, okay, the electronic circuit, and simulate it. Okay, then do the analysis about that electronic circuit. That's all of the thing that LT Spice can do for us. And then the second software is Multisim. So Multisim is quite advanced software, which is also being used in the textbook of electronic device as well. So Multisim is the product of National Instrument. That the advantage of Multisim is basically you are not only can the advantage of Multisim is basically in terms of its functions. Its function is which is more than LT Spice. For example, for LT Spice, what we can do is 2 things, which is construct the circuit, design the circuit, and then do the simulation to analyze the circuit. But for the Multisim, you are not only can construct the circuit, okay, design your circuit, and then do the simulation to the circuit, but also from your hello, aha, courier, ada dah, okay, okay, terima kasih. Okay, so the courier has just arrived, which is, I believe that one is post laju, which is quite slow, post laju. I ordered your, kat mana dah tadi? The software, right? The software Multisim is something, it's more advanced than LT-Spice lah, because LT-Spice is free of charge. Multisim is paid. Something that you want to subscribe the full version, you will need to get a license, in which you have to pay lah. For Multisim, basically what we can do from Multisim is construct the circuit, do the simulation and analysis of the circuit, and then it also has features in terms of we can further design our circuit in the form of breadboard, right? So from our simulation, from our the circuit that we have constructed earlier, the Multisim will prepare some sort of symbol or components that we can arrange in the breadboard to design our breadboard. So that is the advantage of the Multisim. Of course, in terms of components availability, I think Multisim can provide more components compared to the LT-Spice, because LT-Spice is free of charge. And then if we don't have any component from LT-Spice, basically we can add it in the component library. We can just search for the model in the internet. Let's say if we don't have that a particular diode, for example, then we want to use that diode. So basically what we need to do is to go to the Google and then find that model of diode, and then copy paste that simulation model to the library of the LT-Spice, so that we can use it, right? So that is about Multisim. But the problem with Multisim is if we use Multisim, basically National Instrument will provide evaluation version for the student for only 7 days. Just 7 days. When you start when you start install, they are making money from it, right? So just 7 days will be given to the student for the evaluation version initially, but you can extend the evaluation version manually by following the instruction. I think it has already been shared in the WhatsApp group, right? About how you can extend your 7 days evaluation version to about I'm not sure, so more than 40 days of the evaluation. So 40 days is more than enough, I think, to start with our online session and then do assessment. But unfortunately, I think we cannot do the assessment in terms of using the software for answering the test 2 question, because some of you can access to the Multisim, right? So, and then the third software is Autocad. So Autocad is basically advanced software which is provided by Autodesk. And then we are familiar with Autocad. Normally, people use Autocad not only for doing the modeling of mechanical parts or modeling of the building. Also, it can be used for designing the not only the building construction but also the building plan, right? Architectural based design. Okay, so we can do a lot of things using AutoCAD, and in industry as well. So what you are going to use in this lesson about AutoCAD is basically the version of the AutoCAD that is also used in the industry, which is in the industry, maybe industrial based AutoCAD version, but this one is even it is a educational version, but still it has the features that you can familiarize with and try to learn from it, try to learn try to explore all of the features in the AutoCAD, and then try to learn a lot of you can learn a lot of things from AutoCAD. Basically, it might be useful for you if you when you leave UMT and then of apa and then when you prepare your resume for job interview, for job application, for example, you can put some of your skill that you have learned AutoCAD, so that you can just put it that you have experience, some experience of using AutoCAD. At least it is something that can promote yourself when you start getting the job, right? Because AutoCAD is the standard industrial based simulation platform for modeling of the parts of the component, architectural building. Okay. All right. So that's all about practical lecture 1, which is about software. That will cover LT-Spice, Multisim, and AutoCAD. All right. And then the second practical lecture is about breadboard. The second practical lecture is about breadboard, which is breadboarding, right? So basically in breadboarding, it's not much because we have learned about breadboard in our uh, theoretical lecture session. So basically, there is not much thing that you will need to know about breadboard. So so about practical lecture 2, which is related to breadboard, we will just I'm going to show you on how you can assemble the components on the breadboard. Okay. Because even though it looks simple, but still you need to understand about the arrangement of the connections, about the connection of the about the connection behind the breadboard, right? Because if we don't know, then you put components, it will burn out when you connect to the supply. So basically, breadboard is not something too difficult, because even student at the primary school also using this sort of breadboard. Even apa first grade, second grade student also can use. So for the breadboard, we will for the breadboard, and then soldering. Desoldering is the third practical lecture. Okay, breadboard is second practical lecture. Soldering, desoldering, and then testing and troubleshooting. Basically, PL1, PL3, sorry, PL2, PL3, and PL4, which is breadboarding, soldering, desoldering, and testing and troubleshooting. It's not much you can do, because what I will do is just to prepare all of my materials here. Like I have some, I have my soldering equipment. Okay, I have the solder. Then other things that I'm going to use in my demonstration. So basically, if you like to do it at home, you can get all of this equipment, all of these tools. You can get it from DIY also can. Okay, so you can get it because you are going to use these tools as well at home when you do your mini project, right? So why not just, I think it's not so costly for the soldering iron and then solder and all of this equipment. I think you can get it. And then I will use all of these instruments, And then solder paste. This is the solder paste, which is quite useful when we do the soldering, because when we use solder paste, it is much more easier to stick the joint. It will be easier for the joint to stick together when we use the soldering paste. Okay. So what else? Breadboarding. So basically, for breadboarding, soldering, and testing and troubleshooting, we will cover it in just one session. I think enough, or maybe one session, and then if we cannot complete it, we will continue in the following session. So basically, if we do it in 3 hour session, I think it's enough to cover PL2, 3, and 4. Okay, and then finally, the cabinet. Okay, the cabinet is, so for the cabinet, it is basically the practical lecture content about using CAD software. So basically, in the first PL1 practical lecture 1, we are not going to cover AutoCAD. We are not going to cover AutoCAD, but we only cover the circuit simulation based on LT-Spice and then Multisim, right? For the AutoCAD, we only will use it during our PL5 session, practical lecture 5 session, which is the cabinet. So as you can see here, this is the module that has been prepared by Dr. Muhammad Ikman Nizam about the basic principle, basic concept of using AutoCAD. Okay, start from installation, and we will explore more buttons and more tools, how we draw the polar image, and then circle, so and so on. A lot of things need to be covered here. Maybe if it is not enough to cover in just one session, meaning that in 3 hour session, maybe we will proceed to we will continue in the next 3 hour session lah. So these are the module which is 63 pages to cover AutoCAD itself. Okay, so all of the materials are available here. You can download it, save it to your computer, and then in the meantime, what you need to do to prepare for our lab session in the following weeks is to prepare the tools that we are going to use. Okay, not only installing the software, but also but this is optional. I am not going to force anybody to purchase all of this equipment and then to do it at home. Okay, this is optional because we cannot access to our lab physically. So it's up to you to prepare all of these tools at home so that we can do synchronously in live session. Okay, when I do the demonstration here, you will be trying it at home. Okay, so I think what else about briefing of the flow of the lab? Any question related to flow of the lab that we are going to start next week? How about our pool? I think everyone has finished the pool. I've started a pool just now. There is 2 students who cannot if we cover our lab session up to 5, There are 2 students who cannot join. So basically, we will try to start at 1, but basically I will not start at 1 o'clock, because some of you might be going for prayer, or some of you might be having lunch, for example. So I will start a bit late. So from time to time, I will start a bit late. I will announce in the WhatsApp group as well. I will start maybe around 2. Okay, I will start around 2. Then hopefully we will finish around 4. Okay. Okay, we will finish around 4. Okay. So we still have much time since this is week 5, and then next week onwards is start from week 6, 7, 8, 9, 10, 11, 12. 12 mean if 2 hours, if 2 hours, 24 hours. 24 hours is, I think, more than enough. Yes, we still have plenty of time to cover our lab session, because in my previous physical class, basically for the practical lecture based session, it will finish around, I think, less than 10 hours of face-to-face meeting. And then the rest of the lab, normally what we do is to use that lab session to construct mini project. That is normal practice lah for this course. Okay, so for the rest of the lab session, for example, after we finish all of the practical lectures, practical lecture 1, 2, 3, 4, 5, we finish, let's say we finish it up to week 10. Then week 11 onwards, we will use that lab session to consult student. I'm going to use that lab session to consult student on doing their project lah, their mini project. Okay, so if you don't have any question, 14 out of 19 agreed for the lab to start from 2 to 5. Okay, 2 have class. Okay, 3 no answer. So that is the result of the poll. I think you can also see from here. Okay, I'm going to this meeting. So another thing is about software tadi, the software just now. So if you manage to install, for example, LT-Spice, okay, this is the interface of the LT-Spice that I have already installed in my office computer. Then Multisim. So it should looks like this. Multisim 14.2, educational edition or student edition, which is the same. Okay. Since I have installed this one as educational edition, you guys install it as student edition, but basically it is the same thing.
Doktor,
Yeah.
saya ada dah multisim daripada first year dulu tapi dia lain sikit, boleh ke guna?
Boleh, no problem.
Okay.
Version 14.1 lah kalau previous version, right?
Yang saya punya 11.
Daripada course mana?
Eddie,
Eddie ada belajar dah ke Multisim?
ada masa first year lab.
First year lab
E.
electronic device ke? I see. Yang pakai buku Pearson tu?
Saya pun tak ingat dah.
Awak tak ingat buku teks? Awak follow modul je? Saya rasa buku teks Pearson dia akan ada supplementary material provided to the instructor, which is apa nama software tu akan provide kepada instructor Multisim punya simulation tu lah, untuk dia ajar pada session. So tak apalah kalau dah ada, tapi dah ada saya tak, I'm not going to teach you on how you can install the pirate version or whatsoever, crack or something, right? So this is the formal class, so I cannot teach you something that is illegal. So the rest, it's up to your responsibility lah. If you like to install the other version other than the educational version that we have here, maybe you can purchase it from the third party supplier, for example. I think in the Shopee also there's somebody selling this sort of software, which is full version, pro version as well. So it's up to you. That is your initiative under your own responsibility. But basically, what I can guide my student is to make sure that you install. I just give the guideline that you can install the educational version with that evaluation period of 44 days or whatsoever. So basically, what you're going to do at your home, at your computer, at your personal computer, it's up to you, right? Okay, so next is I'm going to brief about your mini project. Okay, so your mini project should start it earlier. You should start it earlier because at least at the moment you are still do not receive any consumables or materials to be used in your for your mini project, right? Because I will be for your mini project, basically I'm still preparing the component, which is some of the components like driver for the LM385, which is still not here. Our lab cannot provide that because we don't have that IC. Okay, also the motor driver IC, comparator or operational amplifier IC. Also, we still don't have it here. So I am ordering it from Shopee. Okay, I order it from Shopee. Some of other components that we are going to use, right? Which is not enough, still not enough. So these are the components that I have ordered from Shopee, which is 293 motor driver, 358 OPM comparator. Okay, this is also IC. Then other components, which is this is the caster wheel. Also, I ordered it for you at my own cost. Okay, I will top up all of these component inside your bag. Okay, inside your components bag here, and then I will pack it and ship out to you at the earliest, maybe next week on Sunday. Okay, because just now I received a call from Post Laju, which is I think Post Laju is quite slow lately, because I have ordered this since 6 November. So now it's 12 already. So nearly 1 week of delivery process is quite slow, I guess. Basically, when we order this, it will arrive us around 2 or 3 days, right? Maximum of 3 days. So when you order, maybe some of your components burn out, your IC burn out, then you want to replace it, make sure that you order from a right place. Okay, for example, this is one of the supplier, one of the shop that I used to purchase my components as well. So Nadi Electzone, Robot Edu is also one of the company that provide electronic components that you can purchase. But make sure for the delivery, for me personally, I prefer to choose JMT lah. JMT or GDEX. Post laju is quite slow. So I will be preparing this component, I will put in this bag, and then once I complete preparing all of those components inside, and then I will ship out to you. Which is where is it? 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 Okay, this one. So, okay. So this is basically the thing that you are going to do for your mini project. Let me just make it okay. So this is briefing about your mini project that you are going to do in group. So from today onwards, I think you will have to prepare, at least form a group, find the leader that you can trust, okay? Find a group members. The leader should assign all of your members the task, right? So make sure all of the members do their own tasks, okay? So from now onwards, try to form a group first. Fill up the form that I have provided to you. List down the names of the members of the group, your matrix number, and then make sure that you appoint one leader, and then the address and the name of the person that I'm going to send this. So make sure you provide the address and the name of the person that will receive this. If you like me to ship out, if you like me to send it by post, all right? If you like to come here, just text to me, WhatsApp to me, so that we can meet. I think you cannot enter, or you cannot get inside the UMT. But if you come, just text me so that we can meet, maybe at the guard area. So that I can pass this to you. All right? Okay. So basically the objective of this mini project is to make sure that you understand, okay? You understand from our practical session, then you can apply some of the knowledge that you gain from our practical lesson to construct, okay? To construct a prototype electronic project mentioned here. Prototype electronic project equipment, which is the line follower robot. Everyone or every group will do the same thing, which is the line follower robot. Okay. Then second one, to expose students to different types of electronic design software. So basically, we will cover the software like FreakZine, Multisim, LT-Spice, and Autocad. So since you are having problem, some of you having problem installing, especially Multisim and Autocad. I'm not sure why you cannot install LT-Spice. It is free of charge, and I think maybe because of your internet connection, right? You will need some space to download. You will need some size of file you have to download. But basically, keep trying. At least, I hope that you can install also LT-Spice ni, which is, I think, quite important for you when you do this project. you are going to design the fully functional schematic diagram of the robot. So if you want to do the simulation, then you will need to use LTSpice. If you want just to construct it, just to make sure the component is arranged, some things like that, just use FreeZing. So FreeZing, we cannot do simulation. We just design. Okay, we just design. But for LTSpice, we are not only design, but also we can do the simulation. All right. Similarly for the Multisim, okay, and Easy EDA is another software that, which is Easy EDA is not covered in this lecture, in this course, but basically you can explore on how to use Easy EDA. Then this Easy EDA is basically used for designing the PCB actually, but you can start from sketching your circuit, your schematic circuit as well using Easy EDA. So basically you have to register or download. I'm not sure whether because I've never used Easy EDA, maybe you will have to install and do it online. Sorry, you have to register and do it online for Easy EDA. It is online based software. Okay, like Multisim as well. They provide also online access, which is you can do the simulation on your browser. Okay, so the second thing is the purpose of this mini project is to make sure that students know how to apply the software that has been teach in the formula in the practical lesson, which is such as the FreeZing, Multisim, LTSpice, and so on. FreeZing we are not going to cover in our formal practical lesson, but FreeZing is, I think, primary school kids also can use FreeZing. FreeZing is quite simple software to learn. I think everyone can use FreeZing. So it is not covered in our module for practical lesson module part 1 too, which is the first practical module, the first practical lesson. It is not covered with FreeZing. Yeah? FreeZing is not covered. So you have to learn it by yourself. Try to install. I will give you the link that where you can install FreeZing later in this slide. Okay, and then the third one is for the student to acquire basic skills of soldering and desoldering. Of course, when you start doing your mini project, what you're going to do is to hold this board lah. This we call it as Protobot. This is a Protobot prototype. The board, the PCB or universal board that is used for the prototype, which is Protobot. So basically you will start from this Protobot and then soldering iron, solder, and so on. Put your component and do the soldering and desoldering process. So of course you will do it at your home. When you start doing your project, your mini project, your line follow robot, when you design the circuit and try to do the components, to solder the circuit on this breadboard, this board, alright. So you will learn something lah from there. You will learn how to do a good soldering. Okay, and then basically I will do some assessment for your completed robot. Okay, after you send it to me, I will check on your completed robot, the quality of the soldering that you have made, okay, from your group. So make sure the person who will do this soldering is the right person in your group. Make sure he or she can do good soldering, okay. Something that is we want to avoid some wetting solder, right? The solder is not complete, it's not shiny, or for example. Okay, so 3 objectives need to be achieved in your mini project. These are the problem statement. I think you can read this. So basically, line follower robot is something is quite common now. In industry, for example, they use robot. They use a robot for different applications. Okay. We see in the I have watched something that is from China. When they do quarantine at the hotel in when the pandemic start earlier this year, what they do is to use the robot to deliver food to those who are in the hotel doing quarantine at the hotel, right? So the robot is used to deliver the food, and then in the delivery process So similarly, in this case, the line follower robot also can be used in the warehouse, where the robot is not only not function as a robot that can carry goods or carry items product, but also maybe we can use the robot in terms of doing more advanced thing like well, for example, checking the inventory, okay, checking the stocks, right? So there are a lot of things we can do with robots, and of course a robot can do works 24 hours a day non-stop. We human being, we have limitations. Our normal hours of working is only 8 hours, not like robot. They can work uh, during daytime, nighttime, continuously without stopping. Okay, that sort of thing about problem statement. So which is leads to what we're going to do is to propose a line follower robot. Okay, so what we are going to propose is the line follower robot without microcontroller. If you Google, you will see many types of line follower robot. Some of them use microcontrollers such as Arduino and also Raspberry Pi. Most of the project they use Arduino. Okay, they use Arduino. They put the program, which is this. It gives more flexibility lah. When we use Arduino, we can write our own program. Okay, so that the microcontroller will control the input and output of the sensors part and also motor movement, right? So, but in this case, we are not going to use this sort of microcontroller like Arduino or Raspberry Pi. So for this mini project, it is without microcontroller, in which we are going to use the conventional method, which is using IC. Okay, using IC. So these are the reason why we are interested in building robot without microcontroller. So one of the thing is we want to save costs. Of course, if we buy this microcontroller like Arduino Uno, it will cost you around 30 ringgit for one piece of Arduino Uno microcontroller, which is the original one lah. If you buy a copy one or those from clone one, right? That one must be cheaper. Be much more cheaper. Okay, but for the original one, I think it costs you around 30 ringgit juga. If you go to the reliable websites such as Element 14, for example, they only provide, or Citron Technologies, they only provide original version of the microcontroller, so it will cost more. And then number two, robot is more stable, robust, and it's not a programmable system, meaning that if you use IC, which is IC, which is pre-programmed system. Okay, for example, IC for motor driver, it is already pre-programmed inside it. We cannot edit the program inside it. Then we can use that IC, depends on its rating and its apa nama ni, dia punya, depends on its input and output lah. We can use that IC, so without any programming to that IC, so, meaning that that IC is already been designed in such a way that can work for example, the driver IC, it will be used for driver to drive the motor, right? So that is about IC. So when we use IC, we don't have, there is no need for us to think about program, accessing the software of the microcontroller like IDE for Arduino to design the code for the robot to function, right? For this one, we just use IC, make sure that you know on the connection, the pins, okay, the input and output of the IC, then there will be no problem. Then third one is circuit will not have issue with voltage instability. For the microcontroller, for example, Arduino, sometimes it suffers from instability of the voltage supply. So when you start, for example, when you start your robot, it will start to move, but until sometime during the hard load, which is turning, for example, we lost power because some voltage will drop, for example, because of, as you can see on the Arduino board itself, it has many chips to be supplied, right? Many ICs and also so many components on this board need to be supplied with voltage. So if you use microcontroller, some of the power will go to all of these components, go to this component. Instead of, basically you want to use IC, just one IC, but since it is shared in one board, it will use more power lah. Okay, so if you use IC, basically in terms of voltage instability too, we can avoid lah. Alright, then in our robot system, which is line follower robot without microcontroller ni, basically we use the control of voltage, voltage input to the IC, which is we use 8705 voltage regulator to make sure that voltage supplied to the IC is constant. Then next is easy to tune the sensitivity of the sensors, as IC is used to process the signal from the sensors. So we use specific IC for that specific work, right? For example, to sense the obstacles using IR sensor. Okay, we have IR sensor. So we use this IR sensor as input, and we use comparator, which is IC, 385, 385 IC to process the input from this sensor. So basically, use of this IC, we will not having much more trouble compared to use of the transistor. Because if we use the transistor, it will be hard for us to do the calibration, to do the fine tune of the sensor sensitivity. But if we use IC combined with these IR sensors, it will be much more easier for us to tune the sensitivity of the sensor. Then finally, easy to understand circuit diagram and how it works, as only use IC, no need to understand about program. So we can avoid of doing programming if we use IC, okay? If we use the microcontroller board, we need to think about doing the sketch or doing the programming lah, coding. So for IC, it is essentially based on your knowledge in terms of electronic components, especially the IC input output, okay, supply, VCC, grounding. At least you know lah, you know how to use the IC component. Okay, next is about the sketch, which is hand sketch. So this is basically the system diagram for the line follower robot, which is I have provided to you in terms of hand sketch like this. So what students or you are going to do is to prepare this sketch in a formal form, in the something that you can submit as a report lah. So this one is just sketch, right? So you have to do it properly. Make sure that I think you don't have to use the software to do this. Just use the Microsoft Word and sketch it on the Microsoft Word. So basically, what you need to do with this system diagram is to describe how the microcontroller, how the robot without microcontroller works. Okay, for example, with this simple arrangement of input, controller, and output, I hope that you can describe what happened at the input. Okay, what sort of thing has been processed. Okay, and then controller. Okay, what happened inside the controller, and then at the output, similarly, what happened at the output. So you will have to describe in your report, okay, for each step of the system here. Then, okay, this one is the most important part, which is this is the design drawing, also based on the hand sketch, but all the things that you need to do is to redraw this using software like freezing. I think freezing can do this simply. I think freezing can do this because freezing will have all of the components here. LM358 also available. L293D also available in freezing and other components as well. So you can design this in freezing as your design drawing. But for the fully functional schematic diagram, so this is the circuit design sketch. For the working schematic, you cannot use freezing because in the working schematic, we want to make sure that it is functioning. The circuit that we build is functioning, meaning that we have to do some simulation analysis. So for that, just for design sketch like this one, you can use freezing. At least freezing lah. All right. So how are you going to install freezing? You can just using this briefing slides. Just click on here. Just click on here. So you will go to the browser where you can download, which is from my Google Drive. Just click on here and then download. It's 182 megabytes. You maybe one of you, because not all of you have to download, because I would suggest all of you to download, because you will learn. You can learn doing this at home, using this freezing at home. But basically, at least one member need to download it, which is the person in charge for doing the sketch. For example, you have to download this. You will have to download it at your computer and install. So for freezing, it is not difficult. Download and install, and then it is standalone. basically you extract the file, the zip file just now, then directly go to the executable file, then double click it, then you can directly use it. So this is FreeXing interface, which is breadboarding part. Okay, you can design, put all of the component required here, something like that, and then do the connections, right? Do the connections, something like this. Okay, FreeXing is simple. You can learn it by yourself. There is no need for a formal session to do this. You can learn it from Google, YouTube as well. So this is breadboarding. Then from here you can click to schematics. It shows something like this, which is you can let's say I have switch here. I can just rearrange this component to design my own schematics. So this is PCB design, also available in FreeXing. So we have breadboard, schematic, and PCB design. Only design, not simulation, right? So we can use FreeXing just for design. So that is the thing that you can do. So from this page, you can just click here to download FreeXing and install it in your computer. Okay. For each of the components here, basically I have done some Google just now. Let me just share my browser again. So basically, as you can see from this slide, we have some components, which is important components, which is, for example, LM358. Okay, LM358 is basically a comparator. Okay, a comparator which has the two operational amplifier, 2 OPM inside this LM358. Okay, which is, if you can see from here, it has output terminal at pin number 1, and then input terminal pin number 2 and 3, and then ground at pin number 4, and the other side pin number 5, 6, 7, 8, which is very similar to pin number 1, 2, 3, except for the VCC lah. Okay, so at number 8, pin number 8 is VCC, which is input, 5 volt input. Pin number 4 dedicated for the grounding, and the rest the same, which is input pin number 2 and 3, input for A, then input for B is pin number 6 and 5, then output is 7. So basically, as you can see, when you use this 358 IC, make sure the pin number is connect to the right component. For example, pin number 2 and 3 will be connected to the variable resistor and also 10 kilo ohm resistor here. Okay, so 2 and 3 is the input, which is input from this sensor. Okay, so from this sensor that detects the obstacle here, then from this input it will be processed, do the comparison lah, comparator, right? For example, is the sensor detects black obstacle, what sort of output it should be. Okay, so the output is at the it is not written in this sketch, which is, this is actually pin number 1. Okay, the output is pin number 1, and also the output is pin number 7. Okay, if you use 2 and 3 pin, the output is pin number 1. If you use 6 and 5 pin, the output is pin number 7. So make sure you use the correct output. So basically in this one, LM358, we only use input output A, input output A. for this part. So we use two IC. We use two IC for module 1, the other IC for module 2. But that IC only we use input output A. So we are not going to use input output B. We are not going to use that pin, which is 5, 6, 7 pins. We only use 2, 3, and 1. Okay, 2, 3, and 1 pin. 4 and 8 is grounding lah, grounding and the supply, the IC. Okay, so this is about LM358. Then we have a driver for the motor, which is L293. So L293 is motor driver, which has 1, 2, 3, 4. 4 output. Okay, 4 input output. As you can see, if you Google this, okay, you will see that this L293D has 4 input output. Okay, so the motor will use both input output, meaning that unlike this one LM358, we only just use one input output, right, for that particular module. But for this one, we will use it full output input. Okay, full input output for the motor, right? So make sure that when you do the connections, you know the function of each pin, and then make sure that you do the correct connections. Make sure that when you connect the supply 5-volt supply from 7805 ni, we have 5 volt of supply. We will supply it to this IC. So make sure that the connection of 5 volt is to the right pin. Okay, to the right pin. Okay, so this chip or this IC will use 5 volt. Then it has the corresponding groundings as well. Make sure that the grounding is connected to the ground lah. Okay, so when you use IC, okay, basically it has something like head here, IC head. Then from the left, it starts with pin number 1. 1, 2, 3, 4, 5, 6 to the bottom, and then 9 start from here to the top, which is up to 16 pins. Okay, so next is 7805. This is basically the voltage regulator. We input the battery. The battery will supply 9 volt. Okay, but this voltage regulator will regulate the voltage so that it can output only the constant voltage of 5 volt. Meaning that pin number 1 here, input is 9 volt. All right. Pin number 2 is mana voltage? Where is my voltage regulator? Okay. Pin number 1 is input. Pin number 2 is ground. Pin number 3 is output. So when you input 9 volt here, it will output 5 volt. 5 volt will be supplied to this and then to this chip as well. Okay. So this, all of this IC will consume 5 volt. So make sure that you are not oversupply, or if you direct connect without 7805, then you will burn this IC. It will cost you another 3 ringgit for this IC. Okay. So what else? And then LED, you know, LED has the positive, negative, because positive and negative, because LED is a type of rings. LED is a type of diode, light emitting diode. So diode is basically, it has polarity. It's not like resistor. It's not like resistor. Resistor don't have polarity. You can just assemble it without thinking about its polarity. But for the diode, make sure that you know which part is positive, which part is negative. Example, if you hold this diode, basically what you will see is the longer lead Okay, kaki yang paling panjang, the longer lead is the positive. Okay, the longer lead is positive, the shorter one is negative. And then also we can check the polarity of this diode or LED by observing its head. As you can see, there is a flat head, which is something like this. Okay, flat head, something like this. So that flat area, that flat part is basically negative. Okay, negative polarity lah. So that is the thing. That is the way that we can identify the polarity of a diode. And other is so variable resistor. So you will be provided with the variable resistor as well, which is this one VR. So this is 10K variable resistor. All right. This is another 10K 10 kilo ohm variable resistor. So variable resistor basically it has 3 leads, 3 pins. One is fixed end, one is variable end, and then the other one is fixed end. So make sure your connection is to the right connection. Okay, make sure your connection is to the right connection. Basically, the variable end will be connected to pin 3, for example. So make sure this is the middle pin. The middle pin is the variable pin. Meaning that, as you can see in this symbol, we can adjust by turning this to adjust the resistivity of this potentiometer, the variable resistor, right? So if you can use a multimeter. For example, you can use this sort of multimeter to check the resistivity. Okay. Basically, you can stick your probe to the terminal and then you turn this. You will see that there will be change in the resistivity of this variable resistor. So basically, what you can do is to use the multimeter. I would suggest that you get one multimeter at home, because this is something that very useful for your daily life. For example, if you like to check your power supply, okay, is it has power or not, instead of using like something like test pen, you can use this multimeter to check your power supply at home, right? So it has another function like for this one you can check the continuity. If you use the multimeter, you can check the continuity, which is, for example, if I have the switch, you want to check this switch is functioning or not, we change this dialer to this symbol. I hope you can see this. Change this dialer to this symbol, then make sure that you connect to common and also this one, which is ohmic, which is resistor symbol. Then you put this probe to both sides of pins of your switch. See, when we check the continuity, mean that it is connect that two terminals. When we close the switch, meaning that we short that two terminals. Okay, so when I connect this probe to the both terminal of the switch, so at this moment it is still open circuit. Okay, It is not closed yet. So once I push the push button, you can hear the sound coming from my multimeter, because this switch is already on. So in this situation, this switch is already off. When we on, it is connected. So this is how to check the continuity, which is the connections of wires, for example, from one terminal to other terminal. Okay. So when you use multimeter, you can, as its name, it's multi, right? So you can use for many purpose, like checking the DC voltage, checking the diode, okay, checking the continuity, the resistivity, all right, current as well. I'm not sure whether you understand on how to use this to measure current, this sort of the multimeter type like this. But the one that I have here, I can check the current as well using this clamp. Okay, using this clamp, I can check the current. So basically, this is for high power. For you guys, you just can purchase the simple function one, which is standard one. I think at DIY also sell some of those something like this. For example, this is cheaper type of something like this, but still digital. Still digital. This is one of the affordable multimeter that you can get. Okay. What I am using just now, which is something like this, which has the function of measuring the current as well. There are a lot more different types, different function of the multimeters. All right. So next, I hope we can finish this up to 4, right? Okay. So the next page, the next slide is about packaging plan. Make sure that you can design in your report. Make sure that you can you can provide your own design in terms of packaging plan of your line follow robot. This is from my sketch. It should not something like this in your report. Suppose it is much more complete. All right. So I expect that you will have just provide your idea how you can design your packaging plan. Whether you want to use AutoCAD, or you can use also a much more friendly, user-friendly software like Autodesk Tinkercad. This one you can do it online. Just Google Tinkercad, then you can log into browser-based software so that you can design from there. So this Tinkercad basically used by primary or secondary school students for doing the modeling related work. So I think you can use this to make something like design for this packaging plan of this robot. So next is working schematic diagram. So in addition to the circuit design sketch of this one, so this one is not something like you cannot do the simulation, right? For this one, working schematic, which is something that is you will have to do the simulation and prove that this circuit is functioning, something like that. Okay, make sure that you design properly the circuit, which is looks like something looks like this using the software. LTSpice, Multisim can do this, and also you can use the third-party software like EasyEDA, for example. Make sure that you list down also all of the components available on the circuit of your robot. So for example, for the resistor, you will not have only one resistor, but basically there are more resistors as being used in that line follow robot, right? So you have to list down all of the resistors that you use, for example, and then the potentiometer, okay, Apa lagi ya? Okay. So this is working schematic that you will have also provide in your report. And then this one is optional. This is not compulsory, but if you can provide a PCB design drawing, that will be good. For example, from FreeZing as well, you can design the schematic, and then you can design the breadboard drawing, and then you can also design the PCB drawing, right? So if you can provide the PCB drawing in your report, then it will be an added advantage in terms of evaluation, for example. So, but this is not compulsory. This is optional. You can use also the software like Easy EDA, register to the Easy EDA online, and then try to sketch your own circuit, and then try to convert it or try to sketch the PCB based design of this Easy EDA. Okay. Also, the breadboard drawing is not compulsory, but it is recommended. So it is recommended that you do the experiment on the breadboard first before. So once you get all of these components, make sure that you try to use breadboard lah. Try to use breadboard. Try do the testing on the breadboard first, like the obstacle, check the obstacle, is it functioning or not? Do the fine tuning of the potentiometer, okay? After that, once you confident with the design that you have on the breadboard, then you can just transfer it into this Protobot. Okay, Protobot, yeah. So use this Protobot later once you finish doing breadboarding. Then also in your report, you will need to provide experiment result document lah, something that looks like this, that you have learned it from topic 2, I guess. From topic 2, you have learned on how to prepare the experiment result document when you do the breadboard drawing. So you do the experiment, for example. From your experiment, there must be something that you want to report in terms of your circuit. Is it functioning or not? Okay. What happened during your experiment? What are the procedures that you have taken during your experiment? Okay. What sort of result that you have from your experiment? So all of those things you can provide in terms of experiment result documents. Tools and equipment, I would suggest, not force you to purchase some of the compulsory tools here, like solder iron. So solder iron here, and then solder. Solder tak apalah. Solder I will put solder in your bags as well, in your supplies. Let's say I think this is enough, so I will put this in your supply, in your consumables. We'll send it to you, so you don't need to purchase solder lah. Solder I can share with you, but solder iron I cannot share. This is mine. Okay, and then sponge to clean the tip of the solder iron. Soldering stand, if you want to buy, I would suggest, I would recommend you to purchase something like this with the magnifier glass, and then crocodile clip that you can clip your board, so your board can stand firmly before you do the soldering. So this one is quite good. This one is quite practical if you like to buy the soldering stand. And then the soldering tools, I bought this from Shopee, which cost me not much. I think less than 5 ringgit for this. Also for this soldering tool, you can use this one also, which is less than 2 ringgit. What we call this solder wick. desoldering braid, right? This is the solder wick or desoldering braid. Then what else? Sandpaper. Why do we need the sandpaper? Because before you do the soldering, which is this Protobot is coming out from the factory, sometimes it has some grease, some oil on it. So before you do the soldering, make sure you clean up the surface of this Protobot to make sure it is easily to stick, easily to join. All right. So you can use fine size of sandpaper. Okay, like for example, maybe 500 or 400 size of sandpaper. Just rub it. Just use the sandpaper to make it clean, to make it shiny before you do the soldering, to make sure it is easier for the solder to stick on this board. Then also digital multimeter lah. So digital multimeter is up to you, but you can use it for troubleshooting purpose, for checking your continuity, for example. So if you want to buy it, make sure that it is something that functioning lah. Something that at least you can use it for the continuity check the voltage. You can buy the multimeter, which is something that I've shown you before. Something a cheaper one like this. You can buy something like this, which is much more cheaper. But if you have budget, get something like Rubric is quite expensive. Something that costs around 50 ringgit, which is good for you to keep it at your home, because sometimes you will need it to do the electrical checks at home, right? Okay, next, what else? The list of the components. Next is the list of the components. The list of the components, as you can see, these are the list of the component, which is, as I told you earlier, some of the components is not available, and it has already arrived this afternoon. I will put the components which is still not available. For example, motor driver and also 358 OPM ni, which is still not available, but it has already arrived at home. So I will make sure that all of these components complete before I'm sending it to you, before you come here and pick up, all right? There are some other components for testing. For example, Protobot is also needed. Protobot pin header, wires. I'm not sure if I have the pin header, I will also include in your component. Some wires also has already been given. Then, so this is the list of the components. Make sure when you want to order the additional component, its rating, you know the model of the component, all right? I have given the guideline here in my Excel, in the Excel file. From the Excel file that you have to provide the member's name here. If you go to another tab, you see some other information. Okay. Schematics also here. Don't copy paste this schematic. You will have to sketch your own schematic. And then list of the components. And some screenshot I paste in this Excel file as a guideline for you. If you like to purchase another component, for example, if your components burn out, you will need to get another component for replacement. So you will check, you can have a check on this Excel file that I have include the right component that you can purchase later. Okay, DC motor as well. All right. Okay. So at the moment, okay, this is something important for you guys to make sure that you arrange the grouping as soon as possible. Hopefully we can get at least around 5 to 6 groups. I believe that maybe some of you still don't have any group. Okay, make sure that you assign the leader as well, your leader. And if you like to come here and pick up, just let me know. WhatsApp to me when you are going to come to pick up your stuff. But if you like me to ship out or deliver the consumables or components to you, make sure you provide not only the address, but also your name. Okay? I don't know which name should I put to send this component to Pulau Pinang. Is it Nur Fatin? Is it Nur Fatin? Nur Fatin is not here. No, it's not Nur Fatin. Who is this? So make sure you put your name, not only the address. Sorry, I'm eating curry pap. Make sure the other member of a group, which is this group, make sure you provide the name of the person and also the address that I'm going to ship out all of these components. Make your decision earlier. Okay. And then after the list of the components, so there are important notes for you guys to take note. This is some important notes that you have to make sure that every process, every progress of your work, make sure that you make a record in terms of video or photo record, because you are going to use this to do a video content. Okay, you are going to use recorded video and also photo to do a video content, which is creative content in terms of video. So that represent your team or somebody from your team doing this line follow robot. Make sure that the video is focusing to you as well, not only to the circuit PCB, the board. Okay, the PCB board, right? The PCB board, the project. Make sure that you record the video that focusing on you doing the project. Okay, as a proof that line follow robot has done by you guys. Okay, so to make sure that your project is original, your project is original, it is built by your own team. Okay, Then other than recording the video or photo, the progress of your work to be submitted in the form of video and also final report as well. And then make sure that you prepare the robot according to the scope that's suggested in the project brief, which is the line follower robot without microcontroller. If you send to me the completed robot with microcontroller, that means you did not follow the rules provided in this briefing, right? Provided in this mini project. So make sure that you do the thing that has been instructed in this mini project brief. And then plan your project early to avoid delay. Okay, plan your group earlier. Okay, identify your group leader. Make sure that you receive the component earlier. Don't wait until 1 week before submission deadline. You start this building this robot, right? Make sure that you start earlier. And then final submit the final completed robot to your instructor, to me, for evaluation. So I will be sending this to you. Okay, I will be sending this to you. And when you receive this, make the line follower robot and then return it to me. But you will have to test it at home. Make sure that when you test it, you record the video, photo, for example, to provide content for your report and also your video project, right? So after you finish all of the recordings, all of the necessary things that you need to provide in your report and video, then send it back to me before the deadline, so that when it arrives to me, I can have a check on the build quality of your team, right? Okay, so because if you don't send to me, I cannot check the quality of your work, right? And then the functionality, because I'm going to give marks also. I have 10% marks to be given in the form of complete robot. Okay, so next, what else? This is some guideline for you to prepare your report. Basically, I don't have time to read the report, which is long report. Basically, for the report, it should at least have some less than 10 pages of report. Okay, so don't send me the report which is not something which is not necessary information also provided. For example, some copy paste based some student, they just copy paste. Make sure that you write the report properly. Okay, use your original photo. Okay, make sure it is the report from your team, not something like what we call it as something like something that is not complete lah. Means that you copy paste, you didn't check in terms of grammar, for example, in terms of content lah. Okay, make sure that your report is something that is reviewed by your group, example, before you submit. So the content of your report should consist of front page, introduction page, maximum 2 page. It can be 1 page, all right? And then content. The most important thing is content. Make sure all of these component in the content is available in order to get the full marks of this part, right? Then conclusion and recommendation. It's a 1 page conclusion and also the recommendation. So please check on the rubric on how you can score on the report, right? These are the rubric for report, for video. Sorry, this is the rubric for report. Okay, check the rubric, and this is the report. Sorry, this is the video submission. Okay, so the idea is to submit an original and creative video content. So it's up to you to design your video, but basically I would like to see the something that is I think you can check in the YouTube as well. There are many videos that do the progress of works doing electronics project. Okay, there are many references outside, especially in the YouTube. You can explore it by your team, by yourself. So make sure your video that you submitted is less than 10 minutes. Maximum is 10 minutes.
So, Doctor, in this case, each member will be responsible for different part, right?
Yes, the leader will
Because
assign. Yes, it's up to your leader to assign who will be going to prepare the video, who will be going to do the soldering. So it's up. This is a teamwork. All right.
Okay. Okay.
Okay. So make sure the video have this sort of content. It is something that is project explanation. For example, somebody need to talk to explain how this robot works, for example. Not something like caption-based video. Okay. So it's up to you to design a creative content. Creative content means if, for example, when I receive this, I will post to the YouTube channel, for example. Then I think what I'm going to do is to post it to YouTube channel and then promote it. Which video got something that is attractive in terms of content. So that video must collect some likes, for example. Okay, your video should collect some. I didn't mention here. If you check the rubrics here, video likes. Okay, in the rubric, video likes means that we will post the video for maybe around 1 week or 2 weeks. Then we will have to promote that video. Make sure your friends likes that video to score full marks of video likes. All right. Then the group that has the highest likes of their video will get 5 maximum. Okay. So make sure that you do a good video and then promote. Ask somebody to like your video, like your friends. And then what else? Okay, in your video, make sure that you show the progress of your work from start to end. So this is the rubric for the video content. Then finally, the prototype robot, the complete robot. You will send to me a complete robot, okay, that I will check in terms of the build quality, in terms of design, and then I will check here. I have the track, the lines here, so that I can check. Okay, so maybe we will have a special session for me to check one by one in terms of functionality. So I will use the webcam to pick up robot one by one and then check it in front of you. Okay. Okay. So this is the rubric for the robot hardware. And then what things that you can do next is registration and submission. So for the registration, make sure that all of you registered under one group. Minimum 3, 5 is maximum. All right. So submission, report submission is in e-learn. Video submission is you provide link so that I can download your video, your original size of video, right? Okay. If you send it to me to through WhatsApp, it will downgrade the quality of your video. Make sure that you share it in your Google Drive, then I can download the original quality, original size of the video. And then your robot should be sent to me lah. Due date around 10 weeks from now. Sorry, due date around week 10. And as you can see in the submission system, at the moment, the due date I set is around 18th of December. So you will have more than 1 month to prepare your project. Hopefully, I will receive all of the submission before this due date. Otherwise, if you have some problems, just let me know so that I can consider to further extend this final due date. Some references. So this is a hint. If you Google line follower robot without microcontroller, you will see one of the reference to this project, which is might be useful for your team to do this project lah, right? I think that's all for the briefing about your mini project. It's 3:59, just on time. So is there any question? Any question from the... Yeah?
Doktor, saya nak tanya, kalau untuk kita orang student yang ada dekat Terengganu ni kan, kalau kita orang nak pinjam solder iron yang lab punya, boleh?
Boleh.
Okay.
Tapi saya, sorry, consumables you boleh take out from the UMT. Tapi solder iron, I'm not sure. Saya akan tanya pegawai sains. I will ask the science officer whether you can borrow the solder iron or not. But basically, the solder iron purchased by our lab is not the one that the quality one, because as from my experience from last semester, basically they purchase it from DIY, Mr. DIY, which is for me, which is not a good quality one. In fact, if you order it online, you will get a good quality one, even from China. You can get a good quality one. So I will ask Encik Razman, the science officer, whether you can borrow it. Then we'll let you know later. Any question? Any more question? Tak ada? If you don't have question, Swilan ada question tak? Ada soalan?
Saya tak dengar apa tadi line saya bro. Line saya start tadi doktor.
Pasal borrowing the equipment from the lab ke? So basically, consumables kita boleh keluarkan daripada lab. Maknanya kita boleh keluarkan daripada UMT lah. Tetapi tools kan, tools macam ni saya tak pasti. Saya kena confirm dengan Encik Razman, our lab officer. Boleh tak kita keluarkan ni bagi student pinjam? Saya akan tanya dia. Kalau dia kata tak boleh, maksudnya kena pakat-pakat lah. Pakat-pakat beli. Because you are working in group, right? Kutip lah sikit, RM5 seorang ke. Okay? So
kalau buat meter doktor?
Ya?
Kalau buat meter doktor?
Voltmeter lagilah tak boleh sebab dia voltmeter is asset.
Okay doktor.
Voltmeter is asset. Kalau solder ni dia bukan asset. Dia macam consumables ya juga saya rasa. Tapi tak sure lah kalau if pegawai sains did not allow us to take it away, take it out from its lab, tak tahulah.
Okay, Doktor. Thank you, Doktor.
Multimeter saya pun ada satu je, yang ni tak boleh bagi pinjam, ini harga dia 1,000 kalau bagi pinjam. So kalau multimeter cari yang ada yang RM20 tu, yang warna kuning tu, boleh lah guna untuk temporarily. So any questions? So about soldering iron tu nanti saya akan tanya Encik Man lah.
So, Doctor, can we add one column for the sheet for the mobile number for the groups?
Yes. I think you can edit from there, right?
Yeah. Is it okay to add it?
Okay. If you mean you like to suggest to put another column for contact number of the group members, right?
Yeah, so they can create WhatsApp group.
Okay, I will add because basically you have the numbers from your WhatsApp group, but you don't know which one, right?
Yeah, correct.
You don't know which person. So I will put another column that you will need to provide your number so that people your group can communicate. You can also form a small group lah later. Okay.
Yeah.
So any more question? Tak ada dah. No more question. If no more question, then we will finish up to this time 4:04. Okay, so that some of you can go to another class. Okay, so I think that's all for today. We'll see you again in Monday. Okay, our normal session. Okay, so thank you. See you again.
Thank you, Doctor.
Thank you.
Doktor.
Terima kasih, Doktor.
Sama.